standard form of equations. So up until now we've looked at equations in slope-intercept form. And that form is y equals mx plus b, where we know what the slope is and we know what the y-intercept is. We're going to look at a different form of equations that is a standard form. So the standard form of a linear equation is ax plus by equals c, where a and b are not both 0. So notice a couple things about this equation that are similar to our slope-intercept form. We have an x and a y. So when we look at slope-intercept form, the variables x and y are in there. Those are the variables we use to make our table, if we want to make a table to graph them with. We have an x and a y in this equation also. You'll notice that we have some letters that are different from our slope-intercept form. Slope-intercept form, we use m for our slope, so there's a number there that tells us the slope of the line. We use a lowercase b that represents the y-intercept of a line. That tells you where that line crosses the y-axis. In this form of an equation, we have capital letters. So we have A, B, and C. Now these letters don't particularly give you any information, so I can't look at them and say, oh, that's the slope or that's the y-intercept. I can use them to find some of that information, but they aren't just giving that information to you directly. But this is a form of an equation that we tend to see very frequently, and we can use this form of an equation to help us graph equations just like we've been doing with our slope-intercept form. So let's look at how this form of an equation works. We're going to graph the equation using the intercepts. So we've talked already about the y-intercept. The y-intercept is where your line crosses the y-axis. We're also going to talk about the x-intercept, and we've talked about this a little bit in class. Where does the line cross the x-axis? We're going to look at how we can find those before we've actually done a graph, how we're going to find those, and then we can actually use the graph from those 2 points. So if I said to you graph the equation, and I gave you this equation, you could make me a table. That would work. You could rewrite it so that it's in slope-intercept form and use the y-intercept and the slope to graph the equation. That would work. Or, third way, we're going to use the intercepts. So how do we do that? To find the y-intercept, substitute 0 for x. So here's my equation. I'm going to take out the x and put 0 in there. And then I'm going to do my work to get the y by itself, because you'll notice the x is gone now. So I end up with 3y equals negative 3. I'm going to get the y by itself by dividing both sides by 3. I end up with y equals negative 1. So remember, x was 0, so that means, and y equals negative 1, so I have an ordered pair of 0, negative 1. I'm kind of making a mini table that only has 2 points on it. So my y-intercept is 0, negative 1. Here on my graph, 0 on my x-axis, negative 1 on my y-axis. So there's one ordered pair. There's my y-intercept of this particular equation. Let's find the x-intercept. Again, the x-intercept is on the x-axis, and we know that if we're graphing something on the x-axis, I go side to side for my x value, but then I don't go up and down. So my ordered pair is going to look like a number, and then a 0 where the y is. So to find the y-intercept, we're going to substitute 0 in for y. So again, here's my equation. The y is coming out, and I'm replacing it with a 0. When I do the math here, 3 times 0 is 0. X plus 0 is just plain old x. Don't really need to do any more work to get the x by itself. X equals negative 3. So my ordered pair, since x is negative 3, and I use 0 for y, here's my ordered pair of negative 3, 0. Here's negative 3, 0 on my x-axis. And I'm going to draw a line through those 2 points. So again, this is a third way to see what the line of an equation looks like on a graph. Remember, this line represents all of the ordered pairs. That table that would just take forever and ever and ever to make, which we do not want to make. This line represents all of those ordered pairs. I can find that line 3 ways. We just talked about using the intercepts, so plugging a 0 in for x to find the y-intercept, and plugging a 0 in for y to find the x-intercept, graphing those. We could also rewrite this equation in slope-intercept form and use the b as our y-intercept and use the m as our slope. Or I could make a table. That will always work. So 3 different ways to graph an equation. Depending on what form it's in, you may want to use a different method. Writing equations in standard form. So we've been mostly working with equations in slope-intercept form, and we've talked about how the slope is our rate. How are things changing? Maybe we're talking about miles per hour. Maybe we're talking about dollars per ticket, but it's a rate in our story. And we've also talked about our y-intercept, which is b in that equation, and the b is the beginning, so that might be the beginning of our story. That might be the amount of time that you start with in your story, or that might be a cost that you start with at the beginning of your story. But in our story, in a word problem, that slope, M, and that y-intercept, B, mean something. Remember, we talked about the word interpret. Interpret means tell us what it means in the story. So now we're going to take a look at a word problem, and we're going to write an equation in standard form and see what those pieces mean. So you have $6 to spend on apples and bananas. Hopefully this is not right before lunch and you're hungry. We're going to write an equation where X is the number of pounds of apples and Y is the number of pounds of bananas. If it says apples on your sheet, could you change that? I'm not sure if I changed it yet. So X is apples, Y is representing bananas. So over here we have some more information about the story. They're telling us that bananas are 60 cents per pound and apples are $1.50 per pound. So again, we're using X for our apples, so this is going to be our X, and we're using Y for our bananas, so this is going to be our Y. All right, so to write an equation, again, we always think about an equation. Is there a total? Is there an altogether? Is there a goal amount? And we have kind of this goal amount, this total amount that we can spend of $6. So we're going to put the $6, the total cost, on one side of the equation. And that total cost, that goal amount that we're spending, is made up of how much we're spending on apples and how much we're spending on bananas. Now, how much we spend on apples and bananas depends on how many pounds that we buy. So I'm going to come up with, it's $1.50 times however many pounds of apples that I buy. And I'm going to add that to 60 cents times however many how many pounds of bananas I buy. Because notice these are rates. 60 cents per pound, that's a rate, dollars per pound. I have $1.50 per pound, that's a rate, $1.50 per pound. And remember that the rate will always tell you what to multiply it by. This says 60 cents per pound. Well, my X's are number of pounds. That was my bananas, sorry, that was my Y's. My apple says $1.50 per pound. So this is going to be times my pound of apples. So I'm going to come up with that $1.50. And my bananas is that 0.60 times my Y. Rates will always tell you what to multiply them by. All right, so here's my equation. The total cost of $6 should be equal to how much I spend on apples, and that depends on how many pounds of apples I buy. And 0.60 times Y for my bananas. How much I spend on bananas depends on how many pounds of bananas I buy. Second question, graph this equation. So we've talked about how to take an equation in standard form and graph it. We could make a table, but we know that when we deal with these numbers that are fractions or decimals, it gets a little bit ugly, so I'd rather not deal with a table for this one. We could change this into slope-intercept form. We could absolutely do that. Again, thinking about decimals, I know my slope may not be the prettiest. We could absolutely do that. For this one, let's use that new method that we've talked about, looking at our intercepts. Intercepts also work very nicely with a standard form equation. It's 2 steps, you're done, graph those 2 points, call it a day. So first I'm going to find the y-intercept, and to do that, to find the y-intercept, I'm going to put 0 in for x. I'll have a number for y, but my x is going to be 0. So I plug a 0 in for my x, and I do the math. I come up with 6 equals 0.60y. I divide by 0.60 on both sides, and I get y equals 10. So I have one intercept, my y-intercept of 0 for x, and y equals 10. So there's one intercept. I'm going to go over and do my x-intercept. To find the x-intercept, I'm going to plug a 0 in for y. So here's my 0 in for y. I end up with 6 equals 1.50x. I divide by 1.50, and I end up with x equals 4. So I have my x-intercept of 4, 0. So I'm going over to my graph. Please notice my graph. I have labeled my intervals, so I know what I'm counting by. This is always 0. I've labeled my axes. This is a word problem, so I should have some type of unit on my axes. This is pounds of apples on my x-axis, because we're using the x as apples. This is pounds of bananas on my y-axis. So I have 0, 10, 0, 10 on my y-axis, and I have 4, 0, 4, 0 on my y-axis, on my x-axis. And I'm going to draw a nice straight line. Sorry, that's not the straightest line there, but I'm going to draw a nice straight line on my coordinate plane. So remember, this line gives me all the combinations of pounds of apples and pounds of bananas that I can buy, which will add up to $6. So if I find any ordered pair here on this line, it will give me a combination of those two that will add up to $6. Now the last question is interpret the intercepts. So I'm going to ask myself, what do each of these intercepts mean? So if you remember that our my y-intercept is 0, 10. So up here on my 10 I have pounds of bananas, but you'll notice I didn't go anywhere on the x-axis, which means that I don't have any apples. So this intercept means I can buy 10 pounds of bananas if I don't buy any apples. So if I want to buy all bananas, I can get 10 pounds of bananas. 60 cents per pound. Now my x-intercept down here says 4 and then 0. So 4 on my apple axis and 0 on my banana axis. So that means I could also buy 4 pounds of apples if I don't buy any bananas, which makes sense. Apples are more expensive, so if I'm going to get apples, I'm going to get less pounds of apples, whereas bananas are less expensive, so if I'm going to buy all bananas, I can get more for my money. I can get 10 pounds of bananas, assuming I like bananas, that would be. So we can use our intercepts, and those intercepts, again, mean something as part of the story. Our slope, which it does not ask me about, but our slope here is definitely a negative slope as we go down. And so this is telling me the less bananas I buy, the less pounds of bananas I buy, the more pounds of apples I can buy, which makes sense. If I buy less bananas, I can get more in the apples. So my slope means something also. All right, so using our standard writing an equation from our story, we have a total here, and then we've got our rates multiplied by our variables in this particular case. We can graph this with our intercepts, and we should be able to interpret those intercepts, again, telling what those intercepts mean in the story.